Everyone, my name is Linith Kumar. I am going to explain one-dimensional potential box. This one-dimensional potential box was developed to find out the energy of the particle and wave function of the particle. Here it is the one-dimensional potential box. Let this boundaries of this potential box is x is equal to 0. Let us consider a particle of mass m and let V be the potential energy of that particle. So this is one particle. This potential box contains number of particles. Therefore, the particles may collide to each other. One particle will collide to the other particle, and therefore the collision must be done between the walls of the container also. So therefore these collisions are inelastic in nature. That means there is no loss of energy. Let the boundary conditions are from the Schrödinger time independent wave equation, rho square psi by x square plus 2m by h square whole square into E minus V of psi is equal to 0. Let this V be the potential energy of this particle. This inside the potential box, let potential energy of that particular particle is to be 0. So therefore V of x is to be 0. So consider this equation number 1. Substitute in equation number 1. Rho square psi by 2x square after substituting that value, we get the final equation, that is the equation being true. Rewrite this equation by replacing this particular value 2m by h square whole square into E as k square. Again rewriting it. This equation will be and k square is equal to here it is in the form of quadratic equation. So in order to find the roots of this quadratic equation, we have the solution to find the values of A and B, we may use the boundary conditions. Case 1, if x is equal to 0, then the wave function psi of x is tends to be 0. So therefore, psi of x is equal to a sin of kx plus b cos of kx is equal to 0. While placing the x value 0, so therefore 0 is equal to a sin of k into 0 plus b cos of k into 0. You know sin 0 is equal to 0. So therefore 0 is equal to 0 plus cos 0 is equal to 1. So therefore 0 plus b into 1. So therefore b is equal to 0. Let this equation number 4. Substitute b is equal to 0 in equation number 4. We get psi of x is equal to a sin of kx plus 0 into cos of kx. Hence the equation becomes psi of x is equal to a sin of kx. That is equation number 5. So another condition, case number 2, when x is equal to n, psi of x is equal to psi of L, which tends to be 0. So by substituting that value, 0 is equal to a sin of k of L. So therefore, in sin function tends to be 0 when sin of n pi is equal to 0. So therefore, sin of n pi is equal to a sin of k. Cancelling sin function on both sides. N pi is equal to k, where n is equal to k by k is equal to n pi by n.
K square equal to
from equation number 5, psi of x is equal to a sin of kx. So therefore, a sin of n pi by n equals to find the value of a, we go for the normalization condition. So therefore, after calculating this value, square by 2 into 10 is equal to 1. From that, a square is equal to 2 by n. A is equal to root of 2 by n. By substituting that value in equation number 6, psi of x is equal to root over 2 by n into sin of n pi by n into x. This is the wave function of the particle in one dimension. In three-dimensional, the wave function of the particle will be psi of x is equal to root of 1 8 by m cube into sin of n pi by n into x sin of n pi by n into y sin of n pi by n into z. To find the energy of the particle, from this k is equal to 2m by h cut whole square into e, where h cut is equal to h by 2 pi. So therefore it can be written as 2m by h square by 2 pi whole square into e, or the 4 pi square into 2m by h square into e. K square is equal to here k is equal to n pi by n by squaring on both sides. K square is equal to n square pi square by n square. From that values, the two values of that k, we used to compare the two values of k, 2m by h cut whole square into e is equal to n pi by n. So therefore square pi square by n square 2m by h by 2 pi whole square into e is equal to n square pi square by n square. So therefore 2m into 4 pi square into e divided by h square is equal to n square pi square by n square. Here it represents the energy of the particle in one dimension. So therefore E will be n square pi square h square by 8m pi square into L square. So therefore, energy of the particle will be that pi square get cancelled. L square h square by 8m into L square. Energy of the particle in three dimension. So therefore, E of n is equal to x square h square by 8m into L square. So therefore, E of 1 will be 1 square into h square by 8m into L square. Therefore, E of 2 is equal to 4h square by 8m into L square. E of 3 will be 9h square by 8m into L square. And that is so on. From all these, you can say that the energy of the particle is comprised in terms of n square by n square. So therefore, by drawing the graphs for the particular wave function, this is for psi of x, wave function of order n.
Linith.
Graph for wave function. Psi of x whole square.
Linith.